What would I plug in for x that would make these equal to 0? I would either plug in 0 or I would plug in 5, right? So my x-intercepts are 0 or 5. So what are their multiplicities? What are the powers? 1, x to the first, and then x minus 5 to the first. So they each have a odd multiplicity. So they cut through the x-axis. Kind of a lot to write down, so sorry I didn't give you more room. And then here's my graphing calculator, so I can put up the graph of that. So what does that look like? X times x minus 5. So I should be seeing that it's cutting through the x-axis at each of those x-intercepts. So it cut through, right? Odd multiplicity cuts through. All right, so now I've got x times x minus 3. So what are my two x-intercepts for this graph? 0 and positive 3. And what are their multiplicities? So this one's x to the first, so it has odd multiplicity, and this one is squared, so it has even multiplicity. Right? So at 0, it's going to, I don't have like any room. At 0, it's going to cut through, and at 3, it's going to bounce off. Might need to reformat that question for next year so I can write it down. So let me show you what it looks like. X times x minus 3 squared. So I put it in my calculator. So we should see that it is cutting through at 0. It cut through at 0, and then see how it's bouncing off the x-axis at positive 3. So it's just helping you predict what is the graph going to look like. So the multiplicity of the x-intercepts. All right, this one is not in factored form. So I have to put it in factored form to see the zeros and the multiplicity. So what can I factor out? What's my greatest common factor? You guys sleeping this morning? I can divide by what? 5x. What do I have left after dividing both terms by 5x? X squared from the first term and minus 4 from the second term. Can I go further one step? Your brain should say like, ding, 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 difference of squares, difference of squares. So that can go further. So what should the whole thing factor into? 5x times x plus 2x minus 2. Like your brain should be firing right now. Like, oh, difference of squares. I know how to do that. So I have 3 x-intercepts. One of them is where? 5x. What's going to make this 0? Ansel, what's going to make it 0 here? Yeah, what's going to make x 0? What do I plug in for x? Do I plug in 1? 0. What do I plug in here, Grace? X plus 2. What's going to make that 0? Yep. And Ava, what's going to make the x minus 2 0? All right, so I have 3 x-intercepts. What do you predict about the graph? And why? What's the multiplicity of each of those tell you? The multiplicity was 1 for each one, right? 1, 1, 1. If there's no powers, the power is 1. So if they're all odd multiplicity, what's the graph going to look like? It's going to cut through everywhere, right? Cut through all of them. So let's verify using our graph. 5x cubed minus 20x. So I just put it in the regular format. So it should be cutting through at, so it cut through, cut through, cut through. So it went up, down, up. All right, so that is finding x-intercepts, which you need to know from factoring. And then the one step further was just identifying, is it going to bounce off or cut through the x-axis? And I just remember if the factor has a quadratic like squared, it's going to look like a parabola at that x-intercept. It's going to bounce off at even multiplicities. All right, here's one that we haven't done like this before. So What about writing a polynomial function if I give you the x-intercepts and one coordinate on the graph? So if I tell you that these are the x-intercepts, I do not know the steepness of the graph, but I know what the three factors are. If -2 is an x-intercept or a 0, what factor has to go here as a binomial? Would you agree x plus 2? Because then -2 is one of my x-intercepts. So what are my other two factors? So x minus 3, x minus 5. Are you with me so far? So we're working backwards. This is what I do when I create a test question. I make sure it's factorable, right? Find the answers. Would you agree that this polynomial has all of these x-intercepts and its degree of 3 so far? X times x times x squared, x cubed. Here's the last piece of information, because I don't know how steep this function is. I know that it lies on 2, 36 as one of its coordinates. You plug 2 in for all the x's, you plug 36 in for the y, and you'll be able to solve for a, the steepness of the function. So I'm plugging in 36. I'm plugging in 2 for each of the x values. And you're going to multiply, divide through, and solve for a. So see if you can finish solving for what a would have to be. Is it a big number? Is it a fraction? Is it a negative number? I got 4 times -1 times -3, which is positive 12. So I divided both sides of the equation by positive 12, and I got that a would have to be a stretch factor of 3. So to write your final answer, put your factors back in with the x's, and then just put a 3 in front as your stretch factor. Don't multiply it all out. Just leave it in factored form, and you've satisfied all three of these pieces, like clues to making the function. These are the x-intercepts. It was degree 3. I'd love for you to try this part right here. Find the x-intercepts for each of these and state their multiplicity. And then I will help you sketch the graph in a minute, because we also have to take into account the end behavior. So for each of these two functions, write down what are your x-intercepts and what is the multiplicity of each x-intercept, even or odd. And then we'll sketch the graph down below it. So it's already in factored form. So you should be able to figure out what x has to be. Go together. So you should have gotten that 0 and positive 1 were your two x-intercepts, right? So the multiplicity for this one was even, and the multiplicity is the exponent, right? It doesn't matter that the number 1 itself is even or odd, or the number 0 itself is even or odd. It's the exponent up here. This 2 tells you that it's even. This 1 tells you that it's odd. So if we think about what the graph of this one would look like, we're going to plot 0 on the x-axis and positive 1 on the x-axis. We know that it is going to bounce off at 0, and it's going to cut through at 1, but I need to think about the end behavior to know what the ends of the graph are doing. What's the leading coefficient of this function? So what number is sitting in front of the whole function? Positive 1, right? If it's positive, what's the right side of the graph do? It goes up. And we're going to review that down here in a minute if you forget. And what's the total degree of this function? What would be x squared times x? What's the total degree? Is it a quadratic function? Is it linear? If I put it in standard form, what's x squared times x? X cubed, so my degree is 3, which is odd. If the right side of the graph goes up, what does the left side of the graph have to do? Does it go up the same way, or does it go opposite? Odd is opposite. So let's see, it said it had to bounce off at 0 and cut through at +1. So kind of the end result, and you're going to practice a lot of this on 115, you have to be able to find the x-intercepts, state their multiplicity, and use the end behavior to sketch a graph. So now if I checked out a graph on the calculator, putting all these clues together, x squared times x minus 1 should look pretty close to what I just sketched. I'm kind of far out, but it does bounce off. It goes down a little bit and then back up. If I close my window in on my x-axis a little bit, see if I get closer. So see how it bounces off, goes just below the x-axis and continues through. All right, so what about the other one? What were my two x-intercepts? So my two x-intercepts were -1 and +1, right? And what were their multiplicities? So 3, so odd, +2, so even. All right, so I'm going to plot -1 on the x-axis and +1 on the x-axis. So I'm going to bounce off at 1 and cut through at -1. And I look at my leading coefficient again, and that's positive again, right? My leading coefficient, so the right side of the graph is going to go up. What's the total degree of this function? What would be x cubed times x squared? If I added together all the powers, what power would I have? 5. Would you agree that this would be a degree of 5 if I put it into standard form? X cubed times x squared is x to the 5th. Odd degree, so the left side again is going to go down. So they're going in opposite directions. That's the end behavior of the graph. Now I just need to make this look correct with bouncing through and cutting off. So at -1, it cuts through, and at +1, it's going to bounce off. Cut through, bounce off. This might look a lot different than what the graph looks like. X plus 1 cubed, x minus 1 squared. So because it's a 5th degree, I don't know if it looks like it. Yeah, see, my graph doesn't quite reflect this craziness, but because it's a 5th degree, it's cutting through here. I can't really tell about this turning point, what it looks like, but then it does bounce off here. So, I mean, I've got the gist, the correct end behavior and the bouncing, but I didn't quite get the graph perfect. All right, so here's end behavior practice, which is kind of that other piece that you need. Let's look at the leading coefficient. So you should skim first and make sure these are in standard form, but they look like they're in standard form. So it looks like the biggest term goes first. What does this tell you about the right side of the graph? And how do you know? Is it going to go up or down? How do you know that? Leading coefficient is +1. How does the left side of the graph go? Up or down? And how do you know? Down, but it's not because it's negative, it's because 5 is an odd degree. Does that make sense? Odd opposite. So these have to be opposite each other. So you always do the right side first. So number 2 is going to be what? Right side goes down because -2 is the leading coefficient. Now I look at the degree. The degree is x cubed. So what's the left side of the graph have to do? Is odd again, so opposite, up. Sounds like you don't remember anything about polynomials from Algebra 2. So, all right, this one, what would you say for x to the 10th? Leading coefficient is +1, so up. What about x to the 10th? Are they going to go in the same direction or opposite directions? 10 is even, so they're going to go the same, so up, up. I'm not even going to do this bottom part right now because that's just something that we don't need to focus on in here. So we just need some basic rule learning, not using the infinity and limit notation. But You have to know how to find end behavior of a graph. So these are kind of rules that we need to work on. The guided practice should help that we'll do on 115. All right, so what if you had to sketch, oops, this shouldn't be written here. What if you had to sketch a graph? See if you can do this. So 7a and b, you don't have an equation. They just tell you to sketch a graph that would have an even degree and a leading coefficient that's positive. You can pick any degree you want as long as the degree is even and the leading coefficient is positive. You're just sketching a graph of what this might look like. And then part B, they're telling you the degree is odd and the leading coefficient is negative. So you're just sketching a graph based with some arms. Are the arms going up, down, both the same direction? See if you can do it. I'll put up a couple sample answers in a second. So I'll just give you my couple sample answers. Even degree, that's just a quadratic, right? You could do a nice, like a W shape. That would be like a quartic function, maybe. You cannot do a linear function. You cannot do absolute value. That's not a polynomial function. And then they wanted the leading coefficient to be negative, so that's going down. So they have to go in opposite directions if the degree is odd. So something. Yours could have looked like anything else as long as the two ends were going up, and then this one was down, this one was up. All right, and then 8 was recalling the rule for turning points. So turning points, if it's a linear function, how many turning points does a linear function have? 0 turning points. A turning point is when the graph goes from increasing, it changes direction and goes to decreasing, or decreasing to increasing. That's a turning point. This never changes direction. So you want to look at the degree of the function. So in part B, this is a cubic function, right? It's just not written in standard form. How many turning points could a cubic function have? Could it have 10? So the rule is it can have one less than the degree. So a linear function has 0, quadratic function has 1. So a cubic function could have 2 turning points. It might have fewer, but it could have 2. So see, there's your quadratic. It's only going to have 1 turning point, right? It's going to look something like that, 1 turning point. And then what about D? Someone can do it. What do you think? 5. The power was 6. So at maximum, it's going to have 5 turning points. What if you had to write an equation that has a maximum of 4 turning points? What degree function are you going to write? 4 turning points has to have a degree of what? X to the 5th, right? 1 higher than the number of turning points you want. Then if you want to put something after it, like plus 2x cubed minus 7x plus 8, right? As long as you've got the starting part of y equals x to the 5th, you know that it would have 4 turning points, or a maximum of 4 turning points. All right, we're going to do 9 and 10 together, and then you're going to jump on and do a couple today from 115, because it's basically repeating degree, leading coefficient, multiplicity. If it bounces off or cuts through, that's exactly what we're doing on 9 and 10 to sketch the graph. It says using a graphing calculator. We're to answer the questions and see if we can do it ourselves. So find all the x and y intercepts basically and graph them. So what are my x-intercepts on 9? Say it with me. 0. What else? 1. And -3. So it should be easy to identify the zeros if it's in factored form. Here's 0. Here's 1. Here's -3. I've plotted my x-intercepts. Guess what my y-intercept is? 0. Right? If it's a 0 for an x-intercept, it's also for a y-intercept. If I plug in 0 up here, I'm going to get 0, because I get 0 times -1 times 3. All right, that's my x and y intercepts. Which of these is going to have even multiplicity? Where am I going to bounce off the axis? Yep, I'm going to bounce. right? So multiplicity is even. You don't have to write this, but for these, the multiplicity is odd. It says find the power function. That's just another way of saying find the degree. Would this be x squared, x cubed, x to the fourth? If you multiplied out all those x's, what degree would you get? What's x squared times x times x? You could actually add up all of your multiplicities too. 4. My degree is 4. All right. Determine the number of turning points on the graph. I know that the maximum is 3, but I don't know the turning points yet without actually sketching the graph. So what's the end behavior? What's the right side of this graph going to do? Up or down, and how do you know? How do I find the right end behavior of the graph? What's the leading coefficient? Positive 1. Up. Positive. Up. All right, my degree is 4. That's even. So what's the left side of the graph have to do to be the same as the right side of the graph? Also up. So you start with your end behavior, and then you draw in your multiplicities. We said we were bouncing off at 0. So I'm going to cut through, bounce off, cut through. Looks like a W. And then it says, use your graphing calculator to locate the turning points accurate to 2 decimal places. This might be something you need a refresher on, because I think when we did max and min, people weren't sure what to press. So why don't you grab a graphing calculator and put that function in your y equals menu and see if we can find, what it means is, can you actually identify this turning point and this turning point with a coordinate using your graphing calculator? So we're going to plug in x squared times x minus 1 times x plus 3. So you're going to put that function in your y equals menu and then hit graph. And hopefully you'll get a picture. And if you didn't get a picture, then I should look at your graph. I can't really see the this lower turning point here, so I might have to zoom out in a minute, but I can see this turning point that I'm interested in. And so to find that coordinate, did everyone get a graph to show up? If you didn't, just let me know. But I want to find that turning point right there. I know this one's at 0, 0. I want to find that turning point. So I'm going to go to second trace. See how the word calculate is above the word trace? And I'm going to find a minimum value, choice 3. So I'm going to zoom in on kind of this turning point. So it's going to ask you questions. Are you on the left side of the turning point? So you just kind of move your cursor so that you're on the left. You hit enter. Then you move your cursor to the right of the turning point, hit enter, and then move your cursor back down to your best guess and hit enter, and it should give you your turning point. So it told me my turning point was at 0.69, comma, negative 0.54. And it shows up down here at the bottom of your screen. Did you get that successfully? So I don't really need to zoom out. I know that the turning point's down here. So I really could just move my cursor to the left and the right of the turning point, and then I know the turning point's down here. So go second calculate again. We want to do another minimum value. Use the left arrow to move your cursor to the left side of your turning point. Am I getting there? There we go. I just saw my cursor go by. So there's my cursor. It's on the left side of this turning point, so I'm going to hit enter. Then I'm going to move my cursor till I can see it on the right side of the turning point. Is it coming up here? There it is. There's my cursor. So I'm going to hit enter that I'm on the right. And then I'm going to arrow one more time to the left so that I know that I'm down here on my turning point and hit enter a third time. So can you see if you can identify that coordinate correctly using your calculator? So we did everything else on the graph without a calculator, but to identify turning points, you need a calculator. But when you get to calculus, you won't, because you'll use the derivative to find where the instantaneous rate of change is 0, and you'll figure out that coordinate without needing a calculator. What'd you get? Negative 2.19, comma, negative 12.39. Did anyone get that successfully on their own calculator? All right, the last one together. And then you're going to at least try one from the next page because we're out of here at what, 10:20. Okay. So, number 10, before I start, I need to put this in factored form. How can I put this in factored form to find my x-intercepts? What would be a good strategy to use? Is it greatest common factor, difference of squares, or trinomial? I mean, your brain has to see it by now. Which one is it? It's got to be one of those three if I'm asking you how to factor it. So there is a greatest common factor. What's the greatest common factor? X. X times 1 minus x squared. I divided both terms by x. Can I go further with my quadratic? The answer is yes. So I guess I should say, how do I go further with my quadratic? Is that greatest common factor, difference of squares, or trinomial? Trinomial, you need 3 terms. It's difference of squares. So I can write it as x times 1 plus x, 1 minus x. So it's just not in the normal order. Usually we have x squared first, then the minus 1. We can do it the same, just in the reverse order. So 1 times 1 is 1, x times x is x squared. What are your 3 x-intercepts? Your brain should be like popping, like, oh, I know the x-intercepts. I know how to do it from factored form, right? 0, negative 1, and positive 1. The hardest part is getting it to factored form for a lot of you right now. So what do I do next? I have x-intercepts. I plot them on the x-axis. Negative 1, 0, and 1. So I have to use the degree, the end behavior, and the multiplicity to flesh out what this graph is going to look like. You're not just going to wing it, right? What does the leading coefficient tell you? This is tricky. What's the leading coefficient of this problem? I really should rewrite it in standard form so I don't get tricked. Isn't standard form negative x cubed plus x? So my leading coefficient in standard form is really negative 1. So don't get tricked. All right, it's the biggest term's leading coefficient. So I actually want to go down on the right. And then the total degree was cubic. So I want to go up on the left. So they're opposite directions. What's my multiplicity? Weren't they all 1? 1, 1, and 1, right? Power of 1, power of 1, power of 1, odd, odd, odd. So cut through, cut through, cut through. So it looks like a little S through the origin. So this to me is the hardest problem that you're going to be given on your test on Friday. There's going to be some of quiz 1 on there. Just identify the transformation and graph like an absolute value function. There's going to be some of quiz 2 on there. Factor this or solve this. So those are like the isolated skills. Then this is like putting a lot of skills together in one problem. So I give you one equation without a calculator, and you answer all these things about it. This is like the big analysis of using your skills, right? You know how to factor it, graph it, end behavior, multiplicity. So to me, this is like the hardest of the questions because you're putting together all those prerequisite skills. Then there'll be a couple others, like an application of a quadratic, like we did on 110, where you find the area maybe, or a application of here's a polynomial, where's the maximum value. So you'll have some time to process this because Wednesday is a review day and a quiz. Thursday is a team test review day, and then Friday's your test. So you can already see the end result of what you need to be able to do for Friday. And you've got 4 days to get there. So I know that you guys can do it. So in the last like 15, well, how about do I told you I was going to do a game at the end. Why don't you try this one problem on 115, and then we'll end with a game, okay?